Okay, let's see if everything is fine. Can you hear me from there? It's fine? Raise your hand if it's fine. The volume is okay. Okay. I'm recording with my Bluetooth device, the audio. I hope to have a better audio quality, okay, than the microphone of the laptop, as Professor Masala does. He likes to have good audio quality also for the recordings. Okay, who am I? Let's see if I can write. I cannot use this touch screen. I don't know why from my laptop, but I have another one here, and probably I can use that. I am Antonio Servetti. I am assistant of Professor Masala in this class. I will be present in the labs mainly, okay, or I will substitute Professor Masala in the classroom when necessary. Okay. I'm also from the computer science department and working close to Professor Masala, and it's there's been some years that I'm teaching in this class. Okay, what's the program of this class? First, if you have any question from previous classes or so on, feel free to ask me. Then I know that tomorrow we will start the lab, okay? And you will find already, let me check, where is the browser? Okay, let's use a new screen. Okay, it's GitHub, web application. Okay, so lab code. Maybe there is not yet the text of the next lab. It's 2005. Let's see. Lab 1. Okay. This is tomorrow lab. We will have lab tomorrow and on Friday. Is it right? Three separate teams of students. So for this week, I will ask your student to attend the lab as you have been divided by Professor Masala, because probably everybody wants to come to the lab, and we would like to distribute the number of students evenly between the labs. Okay, I know Friday evening is not so good time slot. Okay, but for this week it's better to divide as Professor Masala said. Okay, then we will see in the next week maybe the number of students will reduce, and so even if you don't come in your slot, we can allow you to have a seat and work together. Okay, but for this week it's mandatory to do a strict schedule. Okay, so I am asked to also check that during the lab. Okay, if there are too much people, I have to ask people that are not in that specific slot to leave room to the others. Okay, I hope this will not happen. Okay, but for this week, better to do something like that. Okay, so this is the text. In the lab, there is me or Professor Madala and some assistant that will help you with the question and so on. Okay, and so we will start working on Node.js, and we will do something close to what we are doing today in the lesson. Here is something called the define library, and here in this class we will do an example that is called the question and answer library. Okay, so it's pretty close to what we are doing now, and to the argument we will see together in this lesson. Okay, what about this lesson? So we have to do some exercises with the constructor function, okay, object in JavaScript. You already saw the theory with Professor Masala. Sure that you hear me from over there, because I don't have the feedback of the audio of the room. So please tell me if the volume is not okay, not loud enough. And so we will see something with the constructors and JavaScript object, so properties and methods. And then when we will write methods, we will start with something that is called functional programming or callbacks. The main idea is that function in JavaScript are objects, and so we can give objects as arguments to the function. We can assign functions to variables. Okay, we can pass function as argument in other function and so on. And the paradigm we will explore is called functional programming. The second argument in this class, together with the examples, will be about managing dates. Okay, it's quite complicated and difficult to manage date, so it's important that we rely always in libraries that assure us that all the edge cases, strange occurrence of leap years or something else are managed. Okay, for example, time zones and so on. So never write your own date difference function and so on. Rely on the library. And we will suggest a library that we have been using for years in this class that is called AJS. And this will introduce us to the idea of a JavaScript project, a library, and so on. Okay? So this is the overview of the class. Any question from your side? Did I forget something? Any doubt? Okay, that's fine. Okay, so we can start from something you already have online. This is the repository. Okay, we have from Professor Masala that is on GitHub. If you would like to see that in the browser, is a separate repository that is called Wix. Okay, in week one, there are some exercises. It's big enough, like this from over there. Okay. So you already did exercise 1 and 2, and now we can do together exercise 3, okay, that is called question and answer. Okay, the idea is to manage a data structure as an array of objects. Okay, there will be some question that can be connected to multiple answers. Okay, so every question has a number of answers that are collected in an array, and you have method to add, maybe remove, query, and so on those answers. So let's start with the idea of what we can say. It's not so correct in JavaScript. We can say, call that class or type, but you know that JavaScript has not the idea of class. Okay, is dynamic typing, but let's say we call it type, and the idea of type is that this object is an instance that has been created with a given constructor. Okay, so the constructor is, let's say, the paradigm that defines the object type. The idea, as I said, is to have answer and question. And as you see, a question has a list of answers, okay, that we are going to manage with those methods. So we can start from a project, and let's get, I have here a scheme just to use the same names for the properties. So let's get this and move to a new file. Okay, S3, Q and A.js. Okay, as always, we don't need this anymore. Okay, and always we start with use strict. Okay, so there are a number of checks that are done by JavaScript by itself, and then let's see what we are going to do. Okay, the idea is to have a constructor for an answer. So as a convention, you know, the constructor is just a plain function, okay? Nothing special. The special thing is the new keyword, okay? That creates a new object, an instance that is populated by those, that is passed and populated by this function. So as a convention, we use the capital letter at the beginning of the name of the constructor, so we are able to distinguish them from other functions, okay? And that helps us to remember to use new, okay, in front of that. So this is an answer, and it will have some parameters, some arguments, okay? And what can we have as parameter? Okay, let's see. The response has been called, in the example that I've been given, is text of the response, okay? And if the user provides us with a string as an argument to the constructor, we are going to save this information in the new object that has been created when we call the constructor. So a new object is created, and it is named this. Okay, Professor Masala will give you more information about what is this, when you see that, when you can use that, when it disappears, and so on. But for now, just stick to this information. In the constructor, you can refer to the new object that has been created, because you used new, with the keyword this. And so to save the text in a property of the object, we just assign the string text, that is the argument. Okay, so this is the argument, and this is the name of the property of the object. Okay, and we can start from this. This is a simple example, and see that we can create a answer A1 that is new answer with some text. Hello world. Okay, let's find is the console? Okay, the terminal. It's we are weeks. We have to move here. Okay, you see the example. We call node. Okay, what's happening? It's happening that automatically, in my case, is running what is called a debug terminal, and so a debugger is attached to the execution of the program. This way, I can put, let's say, a breakpoint here, and let's see if it works. Okay, if I put a breakpoint, the program stops in this point. Okay, and I see here, let's reduce that. Okay, and I see here the variables as usual. This is this object. Okay, this is the answer object, and so on. And I can, let's say, put a breakpoint here, I hope, and when I continue, I stop here, and you see that there is this, that is an answer, and text, that is the argument. Okay, I don't know if I can move further. Okay, and after that, the argument has been copied in the property of the this object. Okay, you see? If let's say the bug doesn't work for you, you just have to hit here, run and debug, and selecting Node.js, you do this exact same thing. Okay, so we can also start the debugging from there. Okay, here that an object has been created, as usual, you know that you can use console.log. Okay, and you print A1. One trick I'm using in the lab and suggesting you in the lab is to tag with a string every log that you print. So if you write A1 here and you pass two arguments, they will be separated in the output by a space, but you gain the fact that when you run the code, okay, you have this label A1 that says you what are you printing. Okay, so you don't have to follow the code and see to which line of code this log corresponds to. Okay, as you see, this is a representation of the object given by the debugger, and it tells you the name of the constructor and a representation of its properties and methods. Okay, in this case, it's a property. Any question about this? Is it clear? Okay, so we can go on, and let's say those are called respondent. Yeah. Then the score, and then the date. And what we can do is to copy everything in properties of the object. This dot respondent equal to respondent. This dot score is equal to score, and this dot date is equal to date. Okay, this is the answer. I think it's all. And okay, we can run that like that. But as you see, we didn't give any value for the parameters, and so the property has been assigned a value that is undefined. Okay, when an object does not exist, has not been a variable, has not been assigned an object, it's undefined. Okay, and so what happened is that JavaScript does not throw an error in this case, but just assign undefined to the property. So better we put some values, and the order of the values when you call the function corresponds to the order when you write it. So Antonio, the score, let's start from a score of 0. The idea is that, like in Stack Overflow, the better is the answer, the more clicks, likes it gets, and so the scores increases, or it can decrease if it's not so interesting or not correct. And as a date, we can start from writing a string, but we can do something better after. Okay, so that's all. A date and some properties. If I can go ahead, let's see the question. The question object type, let's say, is pretty similar, but the difference is that there is a list that we can memorize in an array. So a function with the capital question, okay, with how it's called, text, questionnaire, and date. And in this case, the answers will be added, let's see, with a method, not in the constructor. So when the object question is created, it is with 0 answers, and the answer will be added later. Okay, like when you ask something on a forum, something on the web, you put the question and then you wait for the answers. Okay, so it is not in the arguments of the function. So what we do, again, this text is equal to the argument text. This dot questionnaire is equal to the questionnaire, and this dot date is equal to date. Okay, and then we create, it's called list, that is an array for listing the answers. Okay, so we create Q1, that is a new question. Let's create a silly question for the moment, then we can put a more interesting question. So the question is given again from, let's say, Enrico, that is the professor, Masala, and the date was maybe yesterday. Okay. Remember, at this moment, the date is just a string. And so we can print Q1, that is the question. Okay, this is the answer as before, and this is the question. The text, the questionnaire, the date, and the empty array. Okay, nothing special for the moment. So let's go to something. One thing before that. What happens if we forget the new? Okay, let's try to forget the new. And we run JavaScript. In this case, we have an exception. Okay, can you imagine why we have an exception in this case?
Maybe because we are not allocating the right portion of memory for a new object.
Yes, that's for sure. So without new, there is no new object. Okay, so there is no memory allocated, but even worse, we are trying to access a property of an object that does not exist. Okay, because if you don't use new, this is not allocated, is not created. Okay, and so this will be undefined, as we tried before, and you cannot access a property of something that is not defined, has no reference in the memory. Okay, so this is why we get the error. Let's say if we remove this and we run the program, no error. Okay, so it's not an error to call the construction without new, because it's a function, but it doesn't work. It's not what you are planning to do. Okay, and it can give exceptions while you are using that, because you suppose there exists an object and it does not exist because you did not use new. Okay, but the syntax is just the syntax of a function, so JavaScript will not complain. Okay, so that is a short gag to remember you to use new. Okay, to write a constructor with the capital first letter and then use new. Okay, don't forget that. So something more interesting would be to write a method. Okay, we can start from add. So we can add an answer to a question. Okay, so what is a method? In JavaScript, everything is an object. Okay, so a method is, let's say, a property of your object that corresponds to a function. So this dot add equal to a function. How do you write a function? We can use the short syntax of the arrow function. That is like that. Okay. So add means to give an answer, and the answer that is fully constructed is put somewhere, and in this case in the list. So this is the answer. Okay, and we get this dot list. Do you remember how to add an element to an array? Push the answer. Okay, in this case we don't have to return anything, so we can write it like that. If you like, you can also put the parentheses, the curly braces. Remember, if it is written like that, what is the difference between writing a function, an arrow function like that, or with the curly braces?
As a return undefined symbol.
Okay, in this case, it's the definition of a function without a return statement. So return is undefined. The object returned is undefined. No return object. In this case, instead, let's say, the result of this instruction is what the function returns. Okay, so you don't have to explicitly write return. Okay, remember that if you put the curly braces, you have to explicitly write return in this case. Okay, so we don't care about the return. We will not go, we will not read it, so it's okay like that. Either cases, in this case, it's okay. Okay. So what happens is that now we can take Q1 and add A1. And so if we print the question at the end, yeah, there is an error. Cannot set property. Yeah. I did not add new. Okay, what happens is that the debugger prints the content of the object, and you also see a function, but you just have this placeholder for the code of the function. And okay, the list, you can check that in the list there is a new object that you have inserted, and it's the answer we created before. Okay, fine like that. Okay, what happens if we have to create a number of answers? Okay, we can use a loop. Okay, one thing can be something like that. Yeah, we can do something like that. Let's see. A2 equal to hello world 2, Antonio 2, score 0, and so on. Okay, but this is boring. Okay, we don't want to write every question like that. So we can, answers text. We can create an array, okay, where every element is an answer, A1 and A2, okay, but I'm calling there text answer, okay, because what's the difference between this one and this one? So what is the difference between these and these? The strings are the same, okay, but this is an array of strings. This will become an object, okay? So we can start by writing the content of the answers in an array, like this, and then use a loop to create the objects. Const object. We start from an empty array, okay? The idea is this one. We would like to create a number of answers, okay, that is objects of that are instances of the, let's say, class answers. Okay. But instead of writing them one by one like that, we imagine to read them from an array of text or maybe this can be something you read from a file. Okay, every line here is a row of the file with the string separated by comma and so on. So you start from some text information and you would like to create objects. So what you need to do is to give to a constructor all this text, and the constructor will build an object. Okay, so to do that, we create a loop, okay, for let e equal to 0, e less than answer text.length, I plus plus, okay, for every element of this array, we create an answer. It is a new answer. Let's keep it simple. Let's do like something like that. Const answer equal to answer text I. And so the object is created using ans of 0, ans of 1, ans of 2, ans of 3. It is 0, the text, 1, 2, and 3, the other arguments. Okay, and when you have the object, you do answer object dot push. No, let's say we can add them directly to the question, for example. Okay, so we don't need this. We write q1 dot add a. Okay, let's see if it works. Just put a breakpoint here, then run and debug. Okay, we are inside of the loop. Block, okay. I is equal to 0. We have some variable, answer text. The length should be 2. Okay, there is some content. Element 0 is this one. Element 1 is the other one. Okay, and that corresponds to this structure. So we read the element, the array in position 0, and we save that into ans. That becomes this one. And then we create the object A with new answer and the arguments. Okay, so let's see. A, you see, is an answer now. So we started from text, something that you could have read from a file, and create an object over there. Okay, and the object is something that we can add to the question, and so we add that to the question. And somewhere there is also the question that where is the question? Q1. Okay, and now the list of answer has been populated with the first answer. Okay, and we go on and we can add the second question, answer, and so on. And then at the end we print, oh, it's an error because we don't have this anymore. Let's remove the breakpoint and run everything. Okay. And you see, we have created the two answers, and we have added to the question object, and now they are in the list of answer. Is it okay? Any question about that? Something strange? Okay, this is just to remember you the difference between an array with some strings and the same information that is given to a constructor to build an object. Okay, the difference is that this is an object, and so it can have methods and so on. So just to finish this part, that is on all material. Okay, this is not required, but we can write that. Let's write a function that prints or at least returns the answers that belongs to a question. Okay, so you see we have this list. We want to create a method that we can call find all, that returns all the answers in this list. Okay, question. Okay, what do you think we have to do to write a method like this? This dot find all. Let's suppose for the moment that there are no parameters. Okay, and we would like to return the list of the questions. At the beginning, we can just write this. Okay, and what happens with what is the difference if we implemented this function like this or like this is an alternative? This, or let's say I suggest you also a third implementation, this one. Okay, can you tell the differences between them? So what happens with the first one? We return a copy or the same list? The same list, okay? Because this is like a reference, and we return the reference to the list, so we do not create a copy, okay? Return same list, a reference, okay? What happens in this case? Why did I put, how it is called, this operator, the three dots? The spread operator. What does it do? Okay, it spreads all the elements in the array list separated by a comma. So by this way, I'm creating something like A1, A2, and so on. So this is a new array, okay, with the reference to the answers, but it's a new array. Okay, so returns a new array of the same length, where each element is a reference to the answer. Okay, so I can access the answer, change something, don't have to do that because if you are using object programming, there should be a method to do that, so you go through a method. But given that you have the reference, you can do anything with that object, the object that has been stored here in the list. And so what I achieve with this syntax, yeah, I'm returning the same array inside another array. So it's something like that. Okay, this is this dot list. Okay, so to access the element, I need to access two arrays.
The array inside is the reference to the first one.
The array inside is a reference to the first one. Yeah. The difference is that here the array is, the list array is encapsulated inside another array. Okay, here you have one array only. Here you have an array inside an array. Okay, so usually, since the copy is quite fast, we prefer to have a solution like that that returns a copy of the array. Okay, mainly because, like in this example, we don't want to return the whole list of answers, but just a set of them. Okay, so we create a new array with only the reference of the answers that are required. So let's try to test this solution, and then we build the one requested from the exercise. Okay, so console.log q1 find all q1 dot find all. Okay, we run this. Okay, so this is the result. As you see, again, what is the difference between these and these? Okay, when you print Q1, you get the whole object with all the properties and the list of the answer. But when you call Q1 dot find all, you get only the list of the answers, that is this one, that is an array with two answers. Okay? Okay. So now, what is asking the exercise? It's not asking to return all the answers, but only the answers for a given respondent, whose name is given as an argument of the function. Okay, so what operation we have to do on this list? A filtering. Okay, we have to go through all the answers and keep, that is return, only a portion of them. Okay, and use a condition to check that. So let's write some more interesting answer. For example, this is from Enrico. This is from Antonio. Okay, and maybe another one that is fine. Again, from Antonio, that is yesterday with score 1. Okay, so the filter works like that. It is given a name and returns only the answers that match this name as a respondent. Okay, for example, if we ask to get all the answers of Antonio, we will get the first one and the third one. Okay, so this function find all, let's write it again. We'll have a parameter that is a name and will be more complex. Okay. For example, we need to go through all the answer in the list. Any other suggestion for how to write a for loop that cycles over an array? How many methods do you know? I used the length, okay, the counter with the length. Any other one? For off, okay, for each, we will see for each next time. Have you already seen for each with Professor Masala? Not yet, okay. That's an argument of the next block of slides. Any other technique? For in, maybe it works like that. So this time const a of this dot list. Okay, so what is a every time? What is? Okay, an element of the list. Okay, so is an answer. Okay, the object, the answer object. Okay, and we need to do a check that is the respondent is equal to name. Let's say name. Okay, so if a dot where is the answer a dot respondent. I don't know why I don't have the suggestion. Respondent is equal to name, then add to a list. Okay, so we need to create a list, const ret an empty array, and if it is equal, ret dot push a, and nothing otherwise. Okay, so what's wrong here? Yeah, thank you very much. The array is outside, and then I can return the array. Okay, fine. Is it okay? Can you check the code if it's okay? So I run it. Believe it's okay?
Shouldn't be, if we use the strict equal instead of the, is it an error or?
If we use, oh, okay, really fine. Okay. In JavaScript, yes, you have the double equal or the three equal. That's even better. Okay. So you check that is a string, okay, and it's equal as a content. It's fine because the property is just text. Okay, let's see what happens. We call for find all Antonio. Okay, and it's working. We get only the answer that belongs to Antonio. If we change and we put Enrico, we only get one answer. Okay, it's fine. And in this case, as you see, it's fundamental that you create a new array. Okay, because it's a new data structure that contains the reference only to the answers that you have selected. Okay. Okay. Next, in the next part about functional programming, we will make it more clear. So there are other methods that we can implement, but I will wait the part on functional programming for that. Okay, so we will write them in a different way with respect to this one, that is with the paradigm of functional programming. Okay, before the break, I will go through some slides here to introduce this concept, okay? And maybe we can have a break later before the next exercises. So I just want to ask you a question about functional programming. How many of you have never heard the concept of functional programming? So how many of you, raise your hand, how many of you doesn't know, I've never used something that can be called functional programming and don't know what is what I'm talking about? Raise your hand, please. Not so many. What does it mean? You have already seen functional programming, object programming, class. Okay, okay. So here the idea is the same, and we'll repeat the same thing with JavaScript. The idea is that we stick to functional programming because React requires that you use functional programming to write its component and the function inside the components. In particular, React wants to that your function are pure function. You already, how many of you already know the concept of pure function? Nobody? Side effects? Okay, so maybe it's important to repeat this concept again. Okay, the part about pure function will be explained later by Professor Masala when you will see React. Okay, and we start from the basics. Okay, so the idea is that since in JavaScript functions are objects, we can use object as argument of a function. Okay, so we can give a function another function, and let's say delegate to this other function to do something. Let's say, for example, that we would like to create a quote. Okay, compose some string starting from a quote, and this function will output. Okay, will output this quote somewhere. Okay, how do we decide where to output this quote? We decide that not writing something inside the function, but giving a function that is in charge of the output. For example, if we give this function that is called log quote, the meaning of the function can be write this quote on a log. If we instead create another function that can be called, for example, oops, doesn't work. Okay, db quote. Okay. the idea is that giving another function called the b quote, we delegate to this function the output of the quote. And maybe this function writes the quote where? To a db, okay? Or we can give a function called file quote. And this function is written so that the quote is saved in a file, okay? If we look at the log quote function, we see that this function receives a string, and write it somewhere. Okay, if we create another function with a different code inside here, we can, let's say, drive the create quote to behave in some way just by giving another function. What do we see in the create quote? We see that the quote we are given to the create quote is composed with something else, like I always say, and this string is given to the function to do something. Okay, for example, if we create another function that is like that, func air quote, that is the simpler that comes to mind, we can write console.r quote. And so to write the quote on the standard error instead of the standard output, we just need to call create quote something air quote. Okay, the create quote receives the reference to the function in this variable callback and calls the callback with the string. Okay, so if you give log quote, it executes log quote. If you give air quote, it executes air quotes, and the result is different. So you don't change something inside the function, you change the behavior of the function giving a different function as argument. Okay, that's the idea of callbacks. That is a function that is passed to another function as an argument and is called inside the other function. Okay, here JavaScript will use the callback both in a synchronous way and in an asynchronous way. For now, we just see the synchronous way. That is, the callback is called before this function returns. Okay, and the result of the callback, and the callback is completely executed before this function returns. In the asynchronous case, what happens is that the callback is registered somewhere and called in the future. Okay, you don't know when. So this function returns and the callback is still to be called. But not for now. Okay, we stick to the synchronous case. Example of callbacks. You have already seen an example of callback. That is what you did with sort. Okay, you have already used the sort with Professor Masala. Okay, and how does sort behave? You can manipulate. So let sort behave differently, giving sort, let's write here, a callback. This is a callback. That is another function, okay, that is called by sort, inside sort, for every element in this case of the array on which you call the sort. Okay, that's the idea of callback. So what happens? It happens that for every element of the array numbers, that is 4, that is 2, that is 5, that is 1, that is 3, okay, and multiple times, sort calls this function to do a comparison between two elements and uses the result of this function to decide if A precedes B, is equal, or is successive. Okay? So you can control the behavior of sort with another function. Let's give you some warning. Okay, the first one is this one. Default for the, you can also call numbers dot sort like that. If you don't give any callback, it uses a default callback, okay, a default function for comparing two elements of the array. But unfortunately, this comparison is converts the object in strings. Okay, so if you have numbers, those numbers are ordered in alphabetical order. That means that you will have 1, 1, 0, and then 2. Okay? So it's not the correct order of the numbering, and to have the correct order for the numbers, you have to provide your function, that is this difference. Okay? So remember that. It's okay to sort strings, but when you have to sort numbers or more complex things, you have to give your function, as you already did. The second warning is that I can ask you, if I'm writing like that, and I'm writing console.log this, what do I print? I print undefined, because it does not return the sorted array, it sorts numbers in place. So you can, the numbers array is modified. And in functional programming, this is a huge warning, because functional programming works with immodifiable objects, immutable object, like the strings. Every time you would like to modify one object, you create a copy that is different. Okay, you do not modify the original element. Okay, so the sort function does not adhere, does not comply with the functional programming idea. If you look at the MDN documentation, let's see together, they have introduced recently a new function that is the 2 version of something. Okay, and the 2 sorted is the, let's say, copy version of the sort function. And there are some other function like these. I don't remember the other one. To slice, I think, and something like that. So remember that there are some functions with arrays that are not functional, okay? And so you have to take care of using them correctly. Okay, this is an example. I started with sort because sort is an example of functional programming you have already seen, but does not comply with the functional programming paradigm. So, what is the functional programming paradigm? Let's explain a bit here. It's a paradigm where the developer constructs and structured code using function. Okay, JavaScript is not a functional programming language. There are programming languages that are thought and written and designed for functional programming. But JavaScript can be used as a functional programming language. Okay, so the idea is that instead of declaring how to do things, you use an imperative style that says just what to do and not how. For example, here you call filter with a given function. You don't write how this function works, but only, let's say by the name, what this function will have to do. Okay? And you leave to the implementation of the function the how. And also, let's say this construct, the for loop, is something that is related to the how. How you loop over an array, and the functional programming says, I don't care, any way you like. For with length, for with off, I will not specify that. I rely on a function, and that will be a detail of this function. So you see that functional programming is more abstract. Okay? You don't have all the flow of the code, but you delegate the implementation to another function. So it's like a composition of functions. In fact, you will see a composite function, higher order function, and so on. And another rule of functional programming is that, let me see if you find them. Okay. Better you avoid mutability. Okay. So do not change object in place. So sort, no good. If you need to perform a change in an array, return a new array. That is why they invented to sorted, map, filter, and a lot of other functions that return a copy, a modified copy of the original array, not the same. Okay, those are the main concepts. So, for example, to filter an array, I rely on a filter function that uses a callback. Here is where there is the logic of the filtering, and it returns a new array that is a copy of the original array. Okay, those are the main ideas. Have you any question? Does it fit with your idea of functional programming? Does it work? Okay. So, other points about functional programming. As we said, functions are first-class citizens. That is, they are objects. Okay, so you can assign function to variable, as we have seen till now. You can build higher order function and function composition. For example, what is an higher order function? Is a function that operates on function and takes one or more function as argument. Let's say filter is an higher order function because it takes another function as argument. Okay, there are more complex examples. I will not go through the details, otherwise this lesson would be too short, of interesting higher order function that also return a new function. So they define a function and return a function. Okay, and also composition works like that. Composition is to create a function that takes a function as an argument. Okay, and for example, this function as an argument returns something that is given to argument as an argument to the function. Okay, there are some interesting tricks you can do this way, and maybe we will see some of them during this class, this course. In this lesson, we will focus mainly on chaining. That is quite simple. Chaining means that the returned value of the function is of the same type of the argument. So I give a function an array, I get back an array, like the filter function you have seen before. Okay, I call the function filter on an array, and it returns an array. That means that on the return value, I can call another function. So I can write array. It's quite silly, but I write it like that. Filter something dot. What is this dot is called on what is returned by this. And what is returned by this is an array. So being an array, it has defined the filter function. So it's silly, but I can call a filter on a filter. Okay, and we will see other functions that are different. So I can call a map function after a filter. And so this is called, let me see, this is called chaining. Because I chain, so I call a function over, so the argument, the left side of the dot, over the returned value of a previous function. That is always of the same type of the original, the first one, the array. So every function in the chain always return an array, and I can call another function over this returned array. Okay, I think that's all. Before the example, I think we can stop for a while, 15 minutes. Okay, so we start at 2:45.